with constantly increasing carbon emissions and climate change eating our planet, it is imperative to positively respond to the environmental factors. By designing a net zero building, we aim at reducing carbon emissions and providing comfort to the users even in extreme conditions. Our site is located in Vashi, Navi Mumbai, which has warm and humid climate throughout the year. It is very well connected with roads and railways and has all the amenities nearby. Our site has a total area of 418 square meter, which is surrounded by residential blocks, commercial blocks, public open spaces, and government spaces. The initial structural block was withdrawn from the center and an offset of 6 meters is given from the side boundary for vehicular movement. The center and the corners were subtracted from the block to form central courtyard and the intermediate spaces. This ensures adequate ventilation and lighting throughout the structure. Punctures have been created to allow venturi effect throughout the courtyard. In order to reduce the floor area, steps were introduced on the north side. These steps are treated as terrace gardens to promote urban farming. As the southern side goes up to 7 floors, it provides shade to the building. The open spaces at the entrance act as gathering spaces which can be utilized by the occupants throughout the day. Therefore, maintaining its indoor air quality was important. The plants encouraging dehumidification and oxygen are planted throughout the places. Spaces are planned around the courtyard, enhancing the spatial quality and ensuring the blend of nature with the built mass. The central courtyard serves as a ventilation system for the building by acting as an air court. It offers multipurpose activities such as exhibitions, gathering, and sports. In order to make sure the building stands firm during adverse situations, several strategies have been used to ensure resilience using pile drive foundation and placing them first in the basement to prevent earthquakes. Simulations were performed for depicting load diagram for right sizing of structural members. Load bearing diagrams were generated through simulations to ensure right sizing of the structural members. Dampers were also added in the basement to make it earthquake resistant. This is the diagram showing gradual decrease in energy consumption. The energy efficiency has been further increased by using daylighting at advantage to reduce load on artificial lighting. Efficient light fixtures have been installed which reduce blue light emissions by 30%. Total energy generation is greater than total annual energy consumption. Water demand is reduced by 59.2% using low flow fixtures, aerators, waterless urinals, and low flow dual flush water closers. Rainwater collection on terrace areas, hardscape, and courtyard saves water. By analyzing IMAC comfort chart, we aim at achieving 154 IS ventilation and 80.28% of average uniform daylight illumination. We were provided with the tender of a rectangular shaped building, which was faulty in many aspects and would have caused discomfort to the users. Through various active and passive strategies, we have managed to design a net zero educational building, which benefits not only the current generation, but also the ones to come.